for Secure and Smart Community 1. For our first presenter, this is Si Long Kua. Sorry, maybe I pronounced your name not very well. Going to present on handshake-free secure device-to-device communications for disaster relief operations. Prof, the floor is yours. You have 20.
Thank you. Good afternoon, everyone. My name is Si Long from University of Glasgow, based in Singapore. This is a joint work together with my colleague from Singapore Institute of Technology, Raymond. So the idea of this is actually we started to think about without infrastructure, can we get devices that are in close proximity to secure communication between them without relying on a central key authentication server. And this is especially quite useful in a disaster relief operation where your infrastructure is not available, and how can you securely transmit your data in a device-to-device manner as well as in a broadcast manner that you can broadcast the information to all the devices surrounding you for a search operation, for example. So as you can see, ASEAN is actually quite a disaster-prone area. So we have tsunami, we have earthquakes, and we have heavy floods that's happening, especially in the Ring of Fire region like Indonesia, Laos, and Philippines in particular. And all these disasters that actually cause the connectivity to be broken, right? So you don't have a means to communicate. And when you want to perform a disaster recovery operation, you need to set up some kind of ad hoc networking to enable the relay of information so that all this important information can be relayed to some central server and potentially to the internet for fast rescue operation. So if you look at the, what are the problems and background here, so for example, disaster often disable traditional communication infrastructure that we need to form some kind of ad hoc communication. And there's also lack of connectivities that impedes the search and rescue operation, because we know this is very time critical, right? So every second counts, and we need to quickly set up this communication, and the information needs to be also protected in this secure channel as well. And survivors trapped in the rubble rely on timely rescue operation. As we mentioned, every second counts, right? And there's a strong need for device-to-device communication because there might be many different rescue teams coming from different countries come together as a team to do this recovery and disaster search operation. And we can potentially rely on this device-to-device communication to operate without network infrastructure. So we actually experimented with the 5G new radio sitelink, which enable device-to-device communication. So with the sitelink protocol, you can actually discover device around you, and then you can start to talk to device individually or in a broadcast manner. So it provides an ultra-low reliable latency and high data rates for such scenarios. And on top of this, we actually propose some kind of secure protocol without any security handshake to enable the security between this device-to-device communication. So the target here is that actually this protocol can be used for any kinds of applications. So even for in a normal scenarios, we can also enable device to talk to each other securely. But in particular for the disaster relief operation, I think this is quite crucial because there's no internet access and there's no central key management service available, and devices are belong to different administrative domains, and they don't necessarily have a means to secure communication between them. And to rely on the standard handshake protocol that may involve a lot of overheads and latency and delay. So the idea here is to design a security protocol to enable fast, efficient, and key management, especially for we first want to establish a session key between the communicating devices so that they can talk securely through the channel, either device to device directly or through broadcast. Secondly, we also want to enable the fast rekey or key updates between the communication devices. And lastly, based on this shared secret information, they can perform some kind of authentication and also to encrypt their communication session efficiently. So we have not yet integrated with the 5G new radio sitelink yet, but we experimented with off-the-shelf Bluetooth communication devices using BLE at this point. So the idea here is that we propose a KKF protocol, which is called a keychain-based rekeying function. It's actually based on a chameleon hashing function. So essentially, we are generating a hash chain, right, that are linked from one hash value to another hash value, and it is unbounded, meaning that you can generate as many hash value as you want, and whenever you want to renew the key, you just advance the chain to the next hash value to use as a key, right? So it also facilitates very fast authentication, because when you receive the new hash value, for example, H1, then you apply the chameleon or KKF protocol, then you can verify whether the hash of this H1 in combination with a collision random number will result in the previous hash value. So if you can do this verification correctly, then you know that this is actually from the correct sender, and hence it authenticates the new hash key that is being used. Okay? But the catch for this is that we require a pre-shared key or master key to be included as part of the hash input, right? In this case, as I mentioned just now, the rekey and the key updates is efficient because we just need to advance the key to the next hash key in the hash chain, and then we can use that key for authentication and encryption straight away, right? So in this case, we do not really rely on any central infrastructure or an expensive handshake. And the protocol supports either you do a device-to-device communication directly, one-to-one, or you can do a broadcast, and all the devices around the sender will be able to authenticate the packets itself. So the quick construct of the KKF protocol is, for example, here we rely on the one-way hash protocol called chameleon hash hashing. So you have the input M and a random number R together with the public key, and then you can generate hash value, right? So the idea is that we want to link all these hash value to each other, right? So in order to link this hash value, we need to compute a collision random number, which is R prime here, right, using the private key here. So based on the private key, with a new input, we can compute a collision, and based on the collision, we can then link back the new hash key with the previous hash key, right? So that's the whole idea of it, to generate hash chain, right? In order to verify whether the new hash key is the authenticated one, so what we do is that, for example, in this case, H1, right, we put into the chameleon hash function, and then if the hash value result is the same as the previous hash 0, then we know that the key is authenticated. Okay? So in this way, we're actually forming a series of hash keys using a chain, and then it performs easy verification of the sender's authenticity. Right, so for example, in a disaster relief operation, right, many different teams come together bringing their own different devices. Right? We can first provision all these devices with a master key, and then after that, they should be able to establish their connectivities and also to establish the secure session key easily, right? So there's no handshake required. For example, in this case of one-to-one secure communication, we first generate the initial hash key with the random numbers, plus the master key concatenate with the session ID. Then what we have to do as a sender is just to distribute the M and R, which is public in this case, to the recipient, and then based on M and R, the recipient can generate the hash key, which is used for the encryption key. Then they can start communicating, right? So maybe over a period of time, and they want to renew or to update their key, what they have to do is that the sender will need to generate a collision key, which is R prime, and then it will then broadcast or send the next R random number and the collision R to the recipient, and based on this, the recipient can verify the new hash key and authenticate the sender, and then they can continue to use the next key in the new session, in the next session. The protocol also supports secure multicast or broadcast in this case, because 5G site link itself actually supports broadcast operation, right? So whoever in the proximity receiving the key material will be able to generate the new encryption key, right? So the difference with the device-to-device protocol is that for the broadcast communication, for each of the broadcasts, we actually broadcast the 2 consecutive parameters required to generate 2 hash value consecutively, right? So every time a new broadcast, we encrypt with the latest hash key, right? Because with the 2 hash key value, they should be able to authenticate by checking the latest hash key when hash results in the previous hash key, right? So some of the preliminary experiments that we have conducted here, so we actually did some experiment based on Bluetooth communication, BLE, and using generic attribute profile. It was implemented using C using ECC, elliptic curve, deployed on Raspberry Pi 4.0. So if you look at the performance here, the key distribution, verification, and then we also have the rekey updates, session key verification, encryptions, and also the broadcast creation and verification, right? So I think the main overheads come from the key generation aspects, but if you look at the key updates and the key verification and message encryption, they are pretty reasonable performance. When we also perform the transmission of the message, including the encryption of the key using the protocol. And as you can see, the one-to-one message encryption, the round trip time took about 0.2 seconds. One-to-many message encryption using 0.2 seconds. But if you look at the Bluetooth communication without the KKF protocol, it already took 0.197 seconds. So the majority of the overhead was actually coming from the underlying Bluetooth latency. And the overhead from the KKF protocol and the encryption is actually quite low in this case. So the next step, of course, is to integrate with the 5G new radio systems for real-world deployments, because I think they are quite expensive devices. Apart from the implementation, we also did a formal verification of the protocol using formal libraries called ProVerif to ensure the security properties of the protocol design. So for example, the master secret key is protected, the message and the hash keys are protected and not leaked, the freshness of the nulls and the collision nulls, whether it's resistance to replay attacks, and also the ability to detect any spoofing messages. So it's model checking tools that we run on the protocol to ensure the security of the KKF protocol. So the chameleon hashing has also been used in many other applications. So for example, we use it for smart meter data aggregation in the past, and we also use it for GPS, GNSS signal spoofing, that my colleague will also present later on, and IoT security for device-to-device, robot-to-robot communication in a building, etc. So as a future work, I think we presented this handshake-free protocol that can potentially be used for all IoT-related application, as well as the disaster relief operation here. So we verified the protocol using the model checking. And the next step is actually to implement the protocol on the actual 5G new radio devices. And hopefully we work with some of the collaborators here who are working on disaster relief operation, who want to integrate with our protocols to secure your communication for your disaster relief operations. And we hope to really test out the performance in the real world setting. That's all from me. Thank you, everyone, for your attention.
Okay. Thank you very much, Dr. Longkiev, right? We still have 7 minutes for our Q&A session. Now I would like to open the floor if anyone would like to ask, please.
Thank you. It's a very interesting topic for relief operation disaster. However, I see you want to integrate with 5G satellite hardware. Is any hardware exist or not? And if not, you first one to try on Raspberry Pi 4. How is it compatible with the next 5G, with, for example, radio frequency and resource, because limited resource, and you will implement the software for security encryption. Yeah. That is the first question. The second one is, I see with the security issue, if you share the master key one-to-many, then it's a conflict with the security philosophy. Yeah. how you explain this? Thank you.
Right. Thank you for your question. So I think the first one, the protocol is actually at the higher level, so it can be implemented for any communication platform. So the reason that we did using the Bluetooth is actually because it's easily available for Raspberry Pi for us to do the early prototype, and the library can run on top of the communication layer. So the 5G communication one, we actually did it on the simulator for now. We haven't tested it on the real devices, although we had the real devices. But we think that it's also on top of the communication stack, right? So it's not running at the communication layer. So it will be on the, the IP layer and above, or even their communication layer and above, right? So it should be quite generic. The second question about the master key. So the master key is actually like a permanent keys that you implant into the devices, right? So before all the devices come together, and it will just be bootstrapped with this master key, and then this master key will not be changed for that particular sessions, right? And then based on the master key, they derive the ephemeral or the session key later on, right? So we hope that all this master key will be protected in some secure memory space in the devices and will not be leaked. Yeah.
Yes, master key is secured by hardware, for example. However, you have to share the master key with another one, and so there might be a security problem then.
Right. The master key ideally should be sent out of band, right? So when you just come to the device as a command center before the device is being deployed. So at the command center, we provision a master key to the devices before they go out to the search operation. Yeah. So we don't really, it needs to be provisioned in a secure manner before the devices or the team are being deployed into the field. Yeah.
Yes. I mean, what Professor mentioned is that if you go with one too many and then you do the sharing, that it could against the security protocol that you want to ensure, right? Maybe
no, only the master keys are shared. So when you do the broadcast, you're broadcasting the public material.
So what would be the possible loophole? Just to follow up with this question, what would be the possible loophole that could be a bridge, towards how they can get this in between? There's some maybe human error or how you prevent them. Probably this is something that you could take into consideration.
Yeah, of course. Yeah, I think for the master key provisioning, I think that has to be done in a proper and secure manner. But when it's out in the field, we don't transmit any of the master key information, and only the public information are transmitted. And based on the public information and the master key that are already in the device, they can derive the session key. Yeah.
Right. Yeah.
Thank you. I'm curious about the 5G side lobe.
Yeah.
What is the intended range of operation, both line of sight and non-line of sight? If you know.
If I understand correctly, I think the 5G new radio, the range can be quite far. I think maybe up to 200 meters. Yeah. So I think there were already some applications that use drones equipped with 5G new radio for some monitoring, environmental monitoring operations. Yeah.
Okay. So they were standardized for various applications.
Yeah.
And
so
this is one of which.
Yeah. The new radio is a standard by the 3GPP. Yeah. And then they're also going to use it for vehicle to infrastructure and vehicle to vehicle communication as well.
Okay, so if you look at that type of distance, like 200, 300 meters, there are also some other alternative radio access as well.
Yeah, so we are not specific that it has to be 5G new radio. So whichever communication mediums that's being used for the disaster relief operation, we can be on top of their communication stack. Yeah.
Okay, so we still have 1 minute and a half, so one more question from the floor, please, if anyone. Maybe I would like to ask a little bit in terms of the cost of implementation. This probably like, an estimation when this is going to be implementing in the real world deployment, How much could it be? You say this is very expensive, but do you have any figure in your mind?
So I think currently there are not many devices that are equipped with 5G new radio side link. I think maybe that's the reason that it's expensive. So I think when maybe it becomes more matured, then I think costs will be driven down. So I also mentioned that it's not specifically that we must use 5G site link. We just think that it supports the direct communication quite seamlessly. That's why we say that we could use the 5G site link. But if there's any other application or communication stack that is being used for the disaster relief operation, then we can also build on top. Yeah. So I think currently the 5G site link new devices, I think is about 5,000 per device. Yeah.
Right. Yeah. Okay. So thank you so much, Dr. Longkua. Yeah.
Thank you. Thanks very much.
Now I would like to call upon the second speaker of our sessions, Nurul Husna Ahmad, on the abstract entitled AIoT Enable Smart Traffic Management for Sustainable and Low Carbon Asian Cities. Yeah, Prof, the floor is yours. Please,
Okay.
you may begin.
Thank you, Mr. Chairman. Okay, so good afternoon, everyone. So my name is Dr. Nurul Ahmad. So we'll be presenting a topic on the AIoT Enable Smart Traffic Management for Sustainable and Low Carbon ASEAN Cities. So as we may know, the ASEAN cities, based on the report from the NICT report, says that Jakarta and Bangkok as well loses more than 100 hours every year due to traffic delays. Okay, even the Jakarta is also consistently ranked among the top congested cities globally. So at the same time, these two-wheelers dominate our road, creating additional safety and emissions concerns. So these challenges shows that based on the report on the ASEAN Monitoring and Evaluation Report in 2024, it's called for synchronized and smart mobility upgrade. And to this is the focus of my work is actually more on the junctions, okay? Because today junction depends heavily on the inductive loops and fixed time traffic lights. So this system operates in isolations with limited real-time coordination. So most intersections cannot see what is happening in the next junction, which causing uneven flows and frequent bottlenecks. So without real-time data, and traffic agencies can only react after congestions, as already happened. So this is where AIoT can bring significant transformation. Okay, so the target of our project is to design a scalable, sustainable traffic orchestration model that meets the infrastructural needs of ASEAN cities. So we have 4 objectives to achieve, which is first going to design the data fusion framework that integrates information from multiple sensors, and to develop AI-based traffic control models capable of predicting congestions and adjusting timing automatically. And the third one is to embed a cybersecurity framework, including post-quantum cryptography to protect data and system integrity. And the last one is to implement and evaluate AIoT reference architecture that is ready for future 5G and even maybe ready for the 6G communications. Okay, so this is like a conventional traffic management model that implemented around ASEAN country, I believe that. Okay, so it starts that because usually data mainly comes from loop sensors, and even CCTV usually been used just to monitor the traffic, not to collect the data. And then so there is a very little data analysis and limited coordination between this junction. And all these usually the sensing devices in the traffic controller, where usually at the traffic light there are intersection controller, which is a fixed time, and pre-time plans, and then it's limited and no coordination between the adjacent intersection. And then usually we still use the signal timing base and monitor status signal, and there's no data analysis currently involved. And in terms of the communication and security, conventional password or VPN been used in many of the traffic monitoring system. Okay, so this is where we're going to try to do some enhancement in the current system. Okay, so this is our proposed method to enhance the traffic management model. So first we improvise the sensing layer and control layer by collects multimodal data, including CCTV analytics, the IoT sensors, and implement the LPR and NPR camera as well. And then the edge intelligence layer processes the data locally, detects events, and sends short-term statistics. And then the centralized traffic management layer will fuse the data from multiple edges, runs AI and reinforcement learning models as well, and generates coordinates in the plans. We're also going to investigate in terms of the secure communication layer by using the encrypted 5G channels with built-in post-quantum security measures. Okay, so this will result in a fully integrated and adaptive traffic system. So this is kind of our proposed method where we have conducted the pre-experimental setup, collaboration with one of the state in Malaysia, with the safety department, road transport department from GKR. Okay, so what we did here is actually this project also collaborate with one of industry SME company from Malaysia. So so we have prepared this pre-experimental setup that includes the hardware installation, even the edge processing unit and initial data collection. So these setups allow us to validate our sensing accuracy, and then we can communicate communication stability and eye readiness. So what we did is actually we implement some of the cameras in many junctions to capture the video footage and extract the raw data video. Okay, the video data, and do some car classification and license plate recognition. Okay, so from that we do some data pre-processing analysis to process the raw video data using the Edge AI processor. So from that we can measure the traffic flow, even the traveling times and the waiting delay at the junction and the turning movement counts. Okay, so based on that, at the cloud we develop or refine the traffic signal timing. Okay, and then plans for each junction. So this simulate the optimized timing and evaluate the performance where we fine-tuning the timing plan. So from that, we visualize and analyze the data. So then we integrate this with the traffic controller by providing and configure the traffic controller setting and recommended timing plans. So the KPI successful to the system is where we measure the reduction of traveling times for the connective junctions and reduction in the waiting times. So in terms of the impact, in terms of scientific and technological impact, so the proposed model upgrades a legacy fixed time loop and control into a secure AIoT orchestrating framework tailored for ASEAN intersection. So this is significant in terms of the multimodal sensing data fusions, where we're combining CCTV analytics, roadside sensors, and anonymized mobile network data to improve accuracy in detecting traffic states and incidents. The second one, in terms of the edge intelligence and AI control, where the running detection and prediction and reinforcement learning at the edge allow real-time response and coordinate traffic flows. Okay, and what we would like to investigate in terms of this project and how we can secure the architecture of the communication by ensure the low latency, reliable communication, and strong protection against the cybersecurity attacks. Okay, in terms of the societal, environmental, and policy impact, we can say that for the commuters itself, we will enjoy a shorter and more reliable travel times with safer junction and quicker incident reports. And then in terms of environmentally, it's more smoother the traffic and reduce the idling, fuel consumption, and emission. In terms of the government and the policymaker, it can gain a roadmap aligned with ASEAN smart mobility agendas with built-in cybersecurity and privacy safeguard. So importantly, the system provides a cost-effective path to upgrade the existing infrastructure rather than replacing everything with new systems. So this is the collaborative that the impact in terms of this project can strengthen the regional. So we have divided into 4 based on our objective. okay, where for the multimodal sensing between UTM, VNU, GKR, and PPK's SME company will deploy and benchmark the sensor fusion at the real intersection. And we're also going to develop the co-development between reinforcement learning and AI modules to publish open algorithms and dataset for analysis. And then for the low latency communication system between Telkom U and UTM, try to validate the 5G or beyond 5G slices and quality of safety, for safety critical traffic control. And for embedded cybersecurity is between Thailand and Indonesia for the quantum safe end-to-end security attack for the ITS. So this will integrate into the ASEAN IoT traffic equestrian prototype, where we can share this from a reference platform and testbed. This is our preliminary output and existing capabilities, because we have several working prototypes in terms, especially when we implement this LPR, automatic license plate recognition, for vehicle identification and event logging in real time. So this demonstrates our ability to process rear junction video streams in real time. And we also do some vehicle classification analytics just to measure, to identify which car is at the junction, so that we can measure how long the car will, to estimate the waiting time at a certain junction. And then we also have integrated the monitoring interface into the existing UI database to store the event to support the queries. So in terms of the output for the society, industry, and collaborative outcomes, so in terms of the societies, cities and society, it has proven efficiency gains, where the preliminary deployment have shown that it can reduce more than 50% reduction in average waiting time at the targeted junction, especially at the consecutive signals. Okay, and this project also can be a benchmark for Malaysia, where GKR in one of the states in Malaysia, Selangor, can become a national reference site. So this can provide data-driven guidelines and KPIs for rollout to other states and cities. And for the SME, they can plug in AI-ready modular components, where this encourage a local solution ecosystem instead of full import systems. In terms of the ASEAN collaboration, we can have a regional expertise and capacity building in terms of the joint pilots, shared test bed among student and researcher exchange and co-supervised thesis. We can also replicable this into ASEAN blueprint, okay, where the common architecture and best practice that member cities can adopt and adapt, and then a long-term partnership network where a sustained multi-country collaboration for this project. As a conclusion and move forward, so this AIoT enable will, in terms of the edge cloud and then the PQC-ready traffic equestrian model, so this can upgrade the existing ASEAN junction from fixed time control to data-driven. Okay, so what we are going to deliver in this project is more on the multimodal sensing combination, integration between multimodal sensing, edge intelligence, low latency communication, and embedded cybersecurity as one reference architecture for ASEAN cities. And our preliminary trials indicate that more than 50% reduction in waiting time at selected consecutive junction, which is showing strong feasibility for real deployment. And hopefully this will become a clear guidelines or algorithms and modules that road authorities and SMEs can adopt to scale a smart traffic system across Malaysia and the region. So this this will form a practical model for ASEAN cities, expected to improve travel times, safety, and emissions, and as well to support a local innovation and long-term regional cooperation. So I think that's all from me.
All right, thank you so much, Dr. Husna from University Technology Malaysia, for your very good presentation. Now I would like to open the floor for any questions. Yeah, Prof. Azwin.
Thank you for the presentations. it's very interesting to watch your pictures, you know, especially the traffic jam in Jakarta. Very familiar to me. And my question is simple. When you make the model, you are talking about the traffic light, right?
Traffic light.
The red,
The green
red,
with-
orange, and green, you know,
Yes, yes.
the traffic lights. And you want to arrange the traffic light. Are you also doing the study on why there is what you call it traffic jam like the one in your pictures? I mean, in your pictures you can see directly that most of the car wants to go to the right route, not to the left route. But all the cars who wants to go to the right goes to the left area first. Then they pass through they cut the street to the right road. I mean, it is in your picture. Now, we can have this because if you go there, you can see there, you can have what you call it, informal parking area, informal traffic warden. In your picture, you can see it, you know. Car are parked, you know, at the side part of the road, and it is informal parking area. And you can have informal traffic warden who arrange, okay, you want to go to the right street, but you go to do it fast, go to the left first, then cut the road to the right first. You know, that's kind of things that might be interesting because and I'm not mentioning about the so many projects in the route, yeah, making MRT Jakarta, making you know, so many things, and that cause most of the street becomes half, the width of the street becomes half of the road, you see, and that caused a lot of trouble like this, and so it is. I mean, do you also study more comprehensive as the reason as why you have traffic jam like this, and rather, or only you are focusing on the traffic light only? Thank you.
I can take that into consideration, but currently we are looking at the traffic light junction first, because usually during a peak hour, especially if we have so many junction and the traffic light is not linking correctly in green wave, it also can cause a traffic jam, especially when the police traffic is there. Sometimes it causes more jams rather than we waiting for the traffic light. So by analyze this, by doing this data analysis, maybe it can go more automatically and more can be more smart by learning to make this traffic flow very fast. But that one can also be taken into consideration. But I think if, especially in the junction, if this can go, especially if we already targeting which one to prioritize, especially in which area, for example, in this way, for example, maybe the picture for the Jakarta side, especially, maybe, for example, if there is traffic light down in front of the road, right? So maybe we can give more green with the green traffic light will, the timing for that can extend, because maybe the traffic for the opposite side is less, right? So that's the target for this project first.
Thank you. I have only one suggestion and two small questions, short question. My suggestion is very big problem in every country now, and maybe your project should include all of us, all of ASEAN countries. The one short question is how many input you take, because I see just camera only. And the second one question I think is overlap with Dr. Ashwin already said is output of the system. maybe do a map or a guidance for the other driver, right? It's okay. The first question is how many input for your system? Just only camera or pollution?
Pollution?
Pollution.
Pollution, okay.
Pollution. Or temperature, because so many driver at the headquarters. Then its temperature might be high, for example. Yeah.
Okay, so actually for the sensors, we're going to, this is kind of the sensors that we are doing currently. So involving not just the camera, the eye camera, we also still using the loop sensor, but this for the experiment that we've conducted, usually if the traffic lights is already have a loop sensor, so that we can just use that as a backup, okay? But the rest is based on the AI camera, the LPR, and the ANPR. That is the sensors that we investigate. Because in terms of the pollution, what we have, we did not study in terms of the pollution, but we can make prediction, because when the traffic is bad and your waiting time at the junction is long, so it can produce more pollution based on the gas emissions it produce. So by reducing this, we can reduce the gas emission as well. So that's the target of the project.
Okay, so thank you so much, Dr. Husna, for your time.
Thank you.
So I would like to call upon the final presenter for the session number 5, Dr. Chi Kiet Seo, from the University of Glasgow, Singapore, to present the paper entitled GNSS API, GNSS Abnormally Perception and Intelligent, Artificial Intelligence, Machine Learning Driven. Yeah, please, the floor is yours. You have 20 minutes, 15 minutes for the presentation. Yeah. Oh, okay. That should be okay. We still have some time. We will have an early break for this session. Yeah, this one.
Okay. Good afternoon, committee and audience. So my name is Lawrence Chiket Seo, Associate Professor from University of Glasgow, Singapore. So today I'm going to present a topic on GNS API, stand for GNS Anomaly Perception and Intelligence, which is AI and ML driven. So for GNS itself, is the baseline technology to provide PVT, prediction, timing, and velocity to many smart initiatives. So for example, the GNS timing is to support the smart grid and smart finance for the power synchronizations and of course the timing for all these so-called transactions respectively. At the same time, the GNS timing and prediction is also supporting the smart networks and smart transportations for all these so-called example, 5G communications and navigations for autonomous navigation respectively. But however, GNS, although it's a baseline for all these prediction, timing, velocity applications, but however, it is subject to vulnerability, especially spoofing attack. A very low cost, $200 spoofer, which is currently even much lesser, can meet the so-called sets of false GNS satellite to change the prediction, velocity, and timing for various applications. So it can cause very catastrophic attacks to all these applications. And what kind of attacks that is going to be so-called bring about if the prediction, velocity, and timing has been compromised? That in the various ASEAN countries has been suffering GNS interference, jamming and spoofing threat. For example, Indonesia, Singapore, Malaysia. Drivers spoof their location to Gojek such that the customer at the preferred locations can be assigned to them for their so-called personal interests. At the same time, we also realized that in 2022, there's a collision of crude oil tanker along Malacca Strait, and it has been suspect due to the GNS spoofing or jamming. And in Philippines, there is cases of jamming the autonomous identification systems for the Philippine ships for the Philippine fishermen, because the AIS has been used the GNS for the so-called position informations. At the same time, Manila International Airports also suffer some so-called GPS disruption and cause the service to went down. And of course, there's many cases of illegal signal booster and jammer that cause widespread disruption. So all these have serious concerns in ASEAN country due to all these GPS interference, jamming, and spoofing. The target of the proposed solutions is to introduce a GNS API. The purpose is to address real threat to solve all these so-called, highlight the GNS jamming and spoofing. At the same time, we want to develop a core-based multi-modal AI and ML detection using existing infrastructure at Philippines, Indonesia, and Singapore without any edge device dependency, which I'll show you why later on. And most importantly, we want to position ASEAN as a global pioneer in infrastructure-based GNS security. We have go through a phase 1 prototype approach developments in Singapore. It's funded by our so-called Singapore Authority, funded by the Prime Minister Office. And the purpose is to help Singapore Land Authority to build that so-called core network. And the core network is basically a continuous operating reference station. You can treat it as a base station to receive the so-called the raw GPS signal or GNS signal. So as you see here, for Singapore, there is 9 of them. So they are receiving the sets of GNS signals similar to those on the ground. So they has been treated as a reference stations to complement the ground so-called devices in terms of accuracy. And of course, this phase 1 prototype has been successfully delivered and is done by University of Glasgow, Singapore, NTU, and University of Tokyo in partnership with SLA under the grant of about 800 so-called 800K for this project 2 years ago. But however, there is an issue. Of course, before I talk about issue, let's talk about how this mechanism works. So right now is that, since as mentioned, the 9 base station in Singapore is receiving the sets of same GNS signal. In this case, maybe I highlight is GPS at each devices. So the signal will be received by these 9 base stations, and it will be so-called rubber stamp, create digital signature, and then they will broadcast out, for example here, it will be broadcast out at the so-called one reference station through the SLA cloud and all the way to 4G, 5G internet cellular network, go to the so-called edge devices. In the event of any spoof signal, it's also transmitting a full smooth signal, a fake signal. So the edge devices, maybe autonomous car, drone, or mobile phone, they will be receiving 2 sets of signal. One set is the so-called the real GPS signal. The other set is the fake GPS signal. But however, the real GPS signal has been rubber stamped, digital signature, and therefore, the so-called, since the spoof signal has no digital signature, definitely the edge devices will know that it is a fake signal and you'll reject it. And this is how current system is work. But however, this solution is dependency on the edge. So imagine we have so-called 1 million handphone. So we need this 1 million handphone to communicate with our so-called Singapore cellular network communication. So it is very hard to so-called scale because there's 1 million handphone and there's many edge devices out there. So I think Singapore authority feel that there is a problem in terms of scalability. So therefore, instead of relying on the edge devices like mobile phone also got different brand, got Apple, got Samsung, got Huawei, there's many brands. And of course, there's a need to make sure every subscriber of the edge devices subscribe to the Sarah network, which is not possible. So we are thinking of go to the next phase, whereby we base on the reference device approach. So the proposal is that try to develop a multi-modal anomaly detection and predictive spoofing and jamming analysis at the base station, or rather the core station, and this is what we call core solution. We are trying to integrate multi-modal information such as features like I spectrum, pseudo-range, and data stream at each core. And therefore, after that, we can use AI, ML models engine to build a GNS anomaly signature database. And you see from the slide here, for example, on the right-hand side, the core 1 station has been suffering a spoofing attack to the edge devices like a car or autonomous drone, etc. But at the same time, this spoofing signal is also reaching the core networks, core 1. But however, the rest of the core network, it is free from spoofing, free from jamming, etc. So through all this ML engine, we can correlate actually which region has been suffered attack. And this is very important because next phase of so-called in Singapore, by next year, all the so-called the route pricing no longer based on entry, but based on satellite. So whenever we pass through an area, Singapore authority will charge based on the distance travel, based on the major information that collect from these satellite systems called GNS. So therefore, there's a need to ensure all this so-called information is protected. So at the same time, since we are proposing a multi-modal information at the core stations, this proposal also allows 3 countries to work together to share that so-called attack information. So therefore, example, Singapore Core Network, which is maintained by our Singapore Land Authority, Sirens, and of course Indonesia, INACOR, and of course Philippine Core will be the PitchNet. All these 3 parties can share that so-called signature database to build a GNS signal integrity knowledge for the ASEAN Secure Committee. So that is the purpose for, one of the purpose for this so-called proposed solution. And of course, what is the impact that bring about doing these proposed solutions, and why is it feasible? This because the 3 countries can enable cross-validation of attack patterns and model training for robust GNS anomaly detection system. To achieve the most important, the whole is greater than the sum of its parts. Since there are 55 core stations in Philippines and 484 core stations in Indonesia and of course in Singapore, there is 9 of them. So all these 3 countries can work cooperative to ensure the attack pattern can be shared. And what is the scientific and technology impact bring across? We are shifting the GNS anomaly detection from the vulnerable edge devices to the secure core infrastructures. Among these so-called 3 country core stations, using multi-modal ML and AI integrations of the I spectrums, pseudo-range, and data stream for the preemptive threat detection before the attack propagate to the end user. At the same time, we also pioneer some machine learning approach across all these 3 different core networks, creating robust AI models on these diverse attack vectors across the 3 countries, while at the same time establish the ASEAN as a global leader in the AI-driven GNS integrity solutions. As for the social impact, we are trying to protect the critical infrastructure, especially just now, as mentioned, protecting the Manila airport's safety, maritime navigation along the South China Sea, autonomous vehicle, emergency service, and of course the financial systems. At the same time, we also try to protect the ASEAN digital economy by addressing all these so-called Grab hiring fraud, be it Grab or Gojek, by protecting the system itself. And of course, for Singapore, we are trying to protect the Singapore satellite-based ERP toll collections. And this will enable the trustworthiness of this smart city infrastructure rollout. In terms of collaborative impacts, we are trying to establish a 3-country national so-called research partnership between Philippines, Indonesia, and Singapore, where each nation will contribute that unique threat intelligence and create a collectively AI model. And as mentioned just now, we want to achieve the whole is greater than the sum is part while maintaining individual data so-called confidentiality. And of course, this also creates a blueprint for the regional GIS security cooperation between the academic and government industry. And of course, down here, the team comprises of a few members. First will be from NTU, of course, University of Glasgow, Singapore, and so-called Prof. Taru from University of Philippines, which just now given a speech just now. And of course, Indonesia part will be Prof. Lin Yola, and of course, most important thing is the respective so-called core representative, example from SLA, and of course, from Indonesia and Philippines, and the so-called another professor from University of Tokyo, and currently is a CDO of Location Mine in Japan. And last but not least, what is the outcome that we want to achieve? As mentioned just now, by developing this GNS API software, with these trained AI models that deploy across this core network, we are able to allow all these open source code-based detection algorithms to be shared, of course, with this data fusion pipeline, and most importantly, is validated across the 3-country national infrastructure. And new application domain will be able to enable with a secure GNS applications, such as all these low economic, so-called auto additive economics, and of course, all these GNS verified carbon credit systems of sustainability, agriculture, etc. And in terms of social outcome, we want to make sure that we're able to create a technical documentation for this multi-modal GNS anomaly detection, and perhaps become one of the IO standards for all these core-based positioning integrity. And most importantly, because of the use of the so-called GNS is very prevalent, we want to create a trained workforce for GNS security, especially across the 3 nations, through various workshops and of course certification programs. And of course, in terms of cooperative outcome, because these 3 countries work together, respective partnership, we were able to create a joint IP with all these patent files for all these multi-modal anomaly detections. And outcome here, in terms of cooperative, definitely the 3-country core operators were able to have more discussions and definitely create the next generation GNS researcher across the ASEAN Institute. Finally, the target in summarize is that we want to target to solve critical threat in terms of GNS jamming, spoofing, and of course, we want to make sure we protect the infrastructure for various applications, especially all these smart city IoT, maritime and aviation safety. And the method, in terms of innovation, we are shifting from the edge to the core, such that we can achieve the whole is greater than the sum is part. And in terms of multi-modal AI, we are linking various features at the network level and create the so-called intelligence before the attack propagate. In terms of scientific impacts, we are creating an infrastructure-based GNS security paradigm with open source, and of course, we try to submit. Eventually, if succeed, we can submit the standard to ISO for consideration. And last but not least, this social impact is to protect 680 million of ASEAN population, any incidents that occurred due to GNS spoofing, jamming, etc., and of course, secure the economic systems. And of course, we want to train and improve our GNS security specialists with this so-called cooperative partnership among the 3 nations. That's all for my sharing. Thank you very much.
Okay, thank you so much, Dr. Prof. Kiet Xiao. Now I would like to open the floor for the question. Yeah. Professor Ponchai.
Thank you very much for your interesting presentation. Normally the radius or the operating range of each core station, they are quite far apart, like 50+ kilometers. While the radius of the jamming or spoofing influence is much smaller. How do you bridge these gaps? Yeah.
Oh, yeah, because right now we are trying to shift from the edge to the network. So of course, this concern is valid. Thank you very much for the questions. Currently, we are, based on the Singapore context, and of course, based on the Philippines, Indonesia, we are trying to identify so-called the regions. We are not identifying a particular user. We are trying to identify a particular so-called, when they spoof or when they jam, we are trying to solve a mass attack rather than individual attack. If individual attack, definitely we can base on just now the each device solution. So definitely along the way, we will definitely need to think about what is the so-called the attack vectors that we want to solve. So currently we are trying to solve so-called a mass attack, where the so-called the communication attack will be slightly longer. Yeah.
More like a large scale
Yeah, correct.
like event.
Yeah.
Thank you.
Oh, Prof.
Thank you. Your system depends on digital signature, and to detect the spoof GNSS, how can you trust your GNSS device not to be faked spoofed GNSS?
Yeah.
And the second one is so please the first one, yeah.
Oh, okay.
How do you trust on? You use TPM hardware module or only software module?
Okay. So for the first solutions, just like I mentioned, digital signature, definitely it relies heavily on the edge because you are trying to get the GN signals, then you create a hashing digital signatures and then broadcast to the edge. So of course this is not scalable. So therefore we are trying to propose at the network level, at each core level, they have been installed with a trimmer alloy. Trimmer alloy is a GNS receiver. So therefore, we are collecting features like all these RF features like C/N, carrier to noise ratio, collecting so-called the carrier clock bias, and of course, all these so-called carrier phase information, and the raw so-called navigation message data. So from there, collected by this so-called receiver at the core, then we try to correlate information among all the core stations. Basically, it's a multi-model visions to these AI engines. And then in a normal situation, the output will detect that there's no anomaly. But then when there is a so-called attack here, the signature will change from the norm. Because early on, we really correlate among the core in terms of information. But then right now, there's a spoofer. The information they send, they cannot be influenced. Example, 9 core stations at the same time. Okay? So therefore, they may only affect one. So example, clock bias is only affecting, if you attack, you're only affecting core 1. You're not affecting the rest. But however, early on, when we train the model, we already train in terms of correlation among all the networks. And therefore, this anomaly detection can be easily smoothed out. Yeah.
Also because GNSS device may be faked and send as well spoof signal as well.
Yeah.
And the second one is normal GNSS device can be attacked and can have abnormal behavior. And your system have to detect the anomaly behavior.
Yeah.
Yeah. Right. Yeah.
Correct. So we are so-called detecting at the core, not detecting at the edge. Detecting edge, I think in phase 1 already developed, but then it is not scalable. Yeah. At the core level, we can correlate. Yeah.
Okay, so because of the time limit, I would like to thanks to
Okay.
our
Thank you very
professor
much
for your
for everyone.
presentation.
Thank you.